Good morning, everyone, and welcome to today's maths lesson on area and volume scale factors. Okay, as with all the lessons we've done so far during this lockdown, this is an A star grade topic only. It will only be on the second half of the higher tier paper. I would imagine almost all of you have already had at least one or two lessons on this topic before. So it's more of a recap, but it is a nice juicy topic. So let's go through it. First of all, we've got to talk about what we mean by similar shapes and the linear scale factor. And once we get that nailed, we can go on to area and volume scale factors. Okay, so hopefully you are now looking at two rectangles. One is 1 centimeter by 2 centimeters. One is 2 centimeters by 4 centimeters. Can someone, if that is not on the screen, can someone please turn their mics on and tell me? Otherwise, I will continue. Right, so if we look at the rectangle on the left and compare it to the rectangle on the right, I'm sure you would say the one on the right is twice as big because the length has been doubled and the height of it has been doubled. But even though the sides are twice as big, the area isn't twice as big. As you can obviously see, I can fit 4 of those original rectangles into the one on the right-hand side. So that's a bit weird. That's a bit of a mind blower. So even though the lengths are twice as big, the actual size or its area is not. As you can see, it's 4 times as big, right? So there's the proof of it there. The length goes from 2 to 4, but the area goes from 2 to 8. Right? Now, the linear scale factor is the amount of times bigger that each side is. So in this case, I'm sure you would agree, the linear scale factor is times by 2. And the area scale factor, in this case, is times by 4, because the area is 4 times bigger. And there is no coincidence that 2 squared is 4. Okay, no coincidence at all. So the linear scale factor is the proportional change in the dimensions. So that just means the sides, right? How many times bigger is each side? Whereas the area scale factor is the proportional change of the area, and they are related by this here, right? The area scale factor is the linear scale factor squared. And this only applies to what are called similar shapes. And if the shapes are mathematically similar, then each side is increased by the same proportion, right? So that's the boring stuff. Let's look at a question. So I've got 2 parallelograms, and they are similar. The area of the smaller parallelogram is 15 centimeters squared. What's the area of the larger parallelogram? So what we're going to do, we're going to work out the linear scale factor first. Once we know the linear scale factor, we'll square that to get the area scale factor. And then I can just multiply 15 by that area scale factor to get the new area, right? So let's do it step by step. Right, to calculate the linear scale factor. Now, this is pretty easy. I'm going from 4 to 12. I'm sure almost all of you can suss out that the linear scale factor is times by 3. But if these numbers are not so easy to manipulate, and to get the linear scale factor, you do the big number divided by the small number. Okay, always do that. So 12 divided by 4 is 3, so the linear scale factor is 3. Now the area scale factor is that squared. So the area scale factor is 9. So to get the area now of the bigger parallelogram, I'm just going to do 15 times 9, which gives me 135, don't forget the units, centimeters squared. So let's have a little look at that again, right? So they gave us 2 sides. First of all, they told us the shape was similar. That's important. They gave us 2 corresponding sides. Divide them, big divided by small to get the linear scale factor. Square that to turn it into an area scale factor. And then multiply the area of the smaller shape by the area scale factor to get the area of the bigger shape, right? I'm just going to pop out a second because I think a couple of people are trying to get in. No, it seems okay. Right. Can someone just please type in the chat that they saw that question and they can hear me and everything's reasonably okay right now? Thank you, Paul. Thank you, Paul. Thank you, Katie. Right, okay. Let's go back. Right, so I'm sure that was easy peasy. So let's look at a different one then. This time I got two hearts. It should say they are similar. It doesn't, my bad, right? But assume they are similar. And they've given us the width of this heart and the width of this heart. So by dividing them, I can get the linear scale factor. All right, so the linear scale factor is 12 divided by 8, which is 1.5. I need to know the area. So I'm going to square that to get the area scale factor. 1.5 squared is 2.25. Now this time we're trying to find out the smaller area. So I'm going to get that 99, and instead of timesing by the 2.25, I will obviously divide by the 2.25, and it comes out as 44 centimeters squared. Okay, hopefully no problems there. Right, whoops, sorry, that was a bit quick. Let's look at it again. Divide big by small to get the linear scale factor, square it to get the area, and then you've got to figure out, am I timesing or dividing to get my missing area? Right, two for you to try. Both of these questions involve similar shapes. So you're going to do 10 divided by 8 to get the linear scale factor, square it to get the area scale factor, and then decide if you have to times or divide by the 12. Similarly for the trapeziums, divide them to get the scale factor, square it to get the area scale factor, and then decide if you're timesing or dividing by that number there. So I'll give you 90 seconds to try them, and then we'll quickly go through them, okay? Off you go. Right, hopefully you have done the crescents. So the linear scale factor is 10 divided by 8, which is 1.25. You then need to square that to get the area scale factor, which is 1.5625. Now, they give us the area of the small one, and we want the area of the big one. So we're going to multiply 12 by that area scale factor, and it comes out as 18.75 centimeters squared. For the trapeziums, 13 divided by 2 is 6.5. So the linear scale factor is 6.5. Square that to get the area scale factor, 42.25. And this time they give us the area of the large one, and we need the area of the small one. So I'm going to take that 1521 and divide it by the area scale factor. And it comes out as 36 centimeters squared. Anybody want to fib and write in the chat that they had that correct? Have a quick look. Awesome, awesome, awesome. Okay, I think this is an apt moment. Morning, Johan, mate. An apt moment for me to give you my first dad joke of this half term. And it's relevant because it's about my favorite teacher when I was in school, and her name was Mrs. Turtle. It's a strange name, but she taught us well. She taught us well, Mrs. Turtle. Nothing? Yay! Thank you, Kiri. Okay, it's tough crowd. Right, let's move on. Now, how can you make these questions a little bit trickier? Well, this time I've given you the two areas. Don't know why I'm pointing at the screen. You can't see that. All right, this time I've given you the two areas, and I'm asking for a missing side. So we're going to divide the two areas to get the area scale factor. We are then going to square root that. This time now we'll square root the area scale factor to create the linear scale factor. And once we know the linear scale factor, we can then work out a new side. Right? So it's like doing it a little bit in reverse. So as always, do big divided by small. 300 divided by 12 is 25. That's my area scale factor. That's a nice, easy square number. We can do this one in our head. Square root that now to turn it into the linear scale factor, which is 5. It then says calculate the length of one of the sides of the larger hexagon. So I'm going to get this 4. I'm going to times it by 5, and obviously the answer is 20. Right? Easy peasy. Okay, so I'm sure that's not too challenging for any of you. So if they give you the two areas, you divide them and then square root that to get the linear scale factor, right? So here's one for you to quickly try. The two boxes below are mathematically similar and both have to be wrapped with decorative paper. So that's talking about area because you're wrapping it, so surface area. It requires 3.27 meters squared of paper to cover the large box. Calculate the amount of paper needed to cover the smaller box, right? So this isn't like the one I just showed you. This is normal. Start with get the linear scale factor, 50 divided by 40, square it to turn it into an area scale factor, and then decide if you're going to multiply or divide by that number there, right? So I'll give you 30 seconds to have a go with that. Off you go. So 50 divided by 40, you should have 1.25. Square that then to get the area scale factor, which is 1.5625. They've given us the larger area and we need the smaller one. So we're going to do 3.27 divided by 1.5625. And I've got 2.09, because I rounded it, square meters of paper. Anybody get 2.09 square meters as your answer? Someone please type a yes in for me so I know you're still there. Brill, thank you, thank you, thank you, thank you, thank you, thank you, thank you. Awesome, right. So let's up it a notch now. Then let's look at volumes scale factor. I'm sure you've already sussed out how you do it. You get the linear scale factor, and this time you cube it to get the volume scale factor, right? So it's not rocket science, is it? Right, so it's the proportional increase in volume of two similar shapes, and it's the linear scale factor cubed, right? So no real difference, just a different button on your calculator. So remember, square it for area, cube it for volume. So here's a typical question. The volume of the smaller cylinder there is 20. What's the volume of the larger one, right? So we're going to divide these to get the linear scale factor. We're then going to cube it so it becomes a volume scale factor, and then we'll multiply the smaller volume by that number to get the larger volume. Easy peasy. So linear scale factor is 2.5. 10 divided by 4 is 2.5. Cube that for it to become a volume scale factor. 2.5 cubed, 15.625. And then get the small volume there. Multiply it by the volume factor there to get the new volume, 312.5, right? So pretty much the identical process to area, except you cube the linear scale factor instead of square it, right? So let's have a look at, well, you try one straight away. Let's get straight into it, right? Two storage jars which are mathematically similar. The volume of the large jar is 1.2 liters. Find the volume of the smaller jar. If you're answering liters, correct the two sig figs. So divide these to get the linear scale factor. Cube that to get the volume scale factor. They give you the volume of the larger jar, so you're going to do 1.2 divided by that volume scale factor then to get the volume of the smaller one, and round it properly, please. Right, I'll give you 30 seconds. One sec. I'm in. I'm in the middle of a lesson, so I'm going to be very quick. Can me and Daki on Parents' Evening on Thursday please be together? All right. Okay, no problem. No probs. Okay, thanks. Ta-da! Right, sorry about that, kids. And here we go. So, linear scale factor was 1.25. Cube that to get the volume scale factor, and that horrific number there, but I didn't round it. So the volume of the smaller jar will be 1.2 divided by that number, and you round it to 2 sig figs, and it comes out as 0.61, right? Which I'm sure you got, and I'm not going to ask you to share that in the chat. Let's look at a slightly more trickier one. So this time, I give you the two volumes, right? The smaller carton holds 125 mil. The larger carton holds 200 mil. The question is, what's the height of the larger carton? So this time you're going to divide the two volumes, big divided by small. That will give you the volume scale factor. You then need to cube root it to get the linear scale factor, and then you can multiply that by the 11 to get this height here, right? So make sure you know where your cube root button is on your calculator. For most of you, it'll be above the cubed, it'll be the shift or second F on the X cubed button, right? There, if you can see that. So you need the cube root button here. So divide the volumes, big divided by small to get the volume scale factor, cube root it, that's the linear scale factor, then times it by the 11. 30 seconds to have a go at that. Use your common sense when you get your answer. It's obviously going to be more than 11, but it's not going to be ridiculous. You're not going to get a carton of cream in Tesco's that's like 8 meters tall. That would be a bit silly, wouldn't it, right? So check your answer looks reasonably correct when you do it. So hopefully you got the volume scale factor was 1.6. That's the 200 divided by the 125. Now the common misconception now is kids will cube that number because they've got it in their head, or volume got to cube it. But don't forget, we're sort of going backwards. So I need to cube root it. And the cube root of 1.6 is 1.1696, and that's where I truncated it. So the height of that larger tub is 11 times that number, which I had 12.87 centimeters, which looks and feels about right. Okay, so I hope that's all okay. Let's move on again. Now, going to up it a notch again now, okay? Right, 2 cans of beans. The large can has a mass of 400 grams and the smaller can has a mass of 50 grams. Now you all know that density is mass divided by volume. The density of the cans and the beans are going to be the same. So effectively, those values of mass are the same as referring to as a volume, right? So we can use the 400 and the 50 as volumes. So I can divide them to get the volume scale factor, and I can cube root that to then get the linear scale factor. The question says the label on the smaller tin has an area of 150. Calculate the area on the larger tin. So I need to work out the area scale factor. So let me go through that again. I'm going to divide these to get the volume scale factor. I'm going to cube root that to get the linear scale factor. Then, think about 10 minutes ago, we then square that to get the area scale factor. And we'll use that and the 150 to work out the area of the larger tin. Have a go. 30 seconds. All the numbers are nice and easy. You wouldn't even need a calculator for this one. I rigged it so it was nice and easy. Right, so I'm sure you did 400 divided by 50 is 8. That's the volume scale factor. You should know, let's be honest, that the cube root of 8 is 2. So the linear scale factor is 2. This question wanted us to work out an area though. So the area scale factor would be 2 squared, which is 4. So if the smaller tin has an area of 150, the bigger tin has an area of 150 times 4, which is 600 centimeters squared. And you would lose a mark if you didn't have the correct units, right, on the exam. So be really careful with your centimeters, centimeters squared, and centimeters cubed. Right. Okay, we're pretty much almost there now. This type of question doesn't go any further. This is it. So have a go at this one. I got 2 cones. I'm telling you that the surface area of cone B, the bigger one, is 12.25 times bigger than cone A. So I'm telling you there that the area scale factor is 12.25. So you can square root that to get the linear scale factor. And once you know that, you can cube it to get the volume scale factor. I tell you that the volume of the larger cone is 380, and I want to know the volume of the smaller cone. So you will be dividing 380 by that volume scale factor. And I've asked for the answer to be 3 sig figs. Get the units right as well. 30 seconds, off you go. Press some buttons. Okay, good. I'll have to read out the answers to this one. So I told you the area scale factor was 12.25. So square root that to get the linear scale factor, which is 3.5. Then cube that to get the volume scale factor. 3.5 cubed is 42.875. To get the smaller volume then of cone A, I get my 380 and I divide it by that 42.875, which gives me 8.86. That's 3 sig figs, 8.86 centimeters cubed. Did anybody get 8.86 centimeters cubed? Can someone please write something? Thank you, Yasmin. Thank you, Paul. Thank you, Colin. Thank you, Leah. Thank you, Jamie. Blah, blah. All right. Okay. Now, that's pretty much it. I can't go anywhere else. Your quiz is about to go live in 90 seconds. And can you all please do it straight away? Because some of you last week didn't do the quiz. You came to the lesson and didn't do the quiz. And we use the quiz to monitor your engagement, right, and track your engagement. So please do that. This is what the questions on the quiz are going to look like. They're all multiple choice, as always, 5 of them. This isn't actually the quiz. This is just the type of questions that will be on there. So this one here, let's have some people put A, B, C, or D in the chat. Come on, let's have a bit of fun here. So I'm sure you can all figure out that the linear scale factor there is 2. So you square that to get the area factor, which is 4. So you've got to think, what is there that when I times it by 4 gives me that? So anybody brave enough to put A, B, C, or D? A, there we go, right? So number 1 is B. Thank you, everybody. That's not too difficult, is it? Okay, so let's try a different one. These two shapes are similar. When you see that on the exam paper, your brain goes, right, this is area or volume scale factor questions. Calculate the volume of liquid that the smaller one can hold. So you try this one on your calculator. I give you 2 heights. You're going to divide them to get the linear scale factor. We're then talking about volume, so you will have to cube that to get the volume scale factor. Once you get that, we'll do 1800 divided by that to get the volume of the smaller cylinder, right? So press some buttons on your calculator and then chuck in A, B, C, or D in the chat. I'm going to have to do this one calculator. So scale factor is 2.5. Do that. Right, we've got, I don't know if you can see my calculator, but I've got 115.2, which is answer B. Okay, so the fact that my answer came up was good enough, right? Very good. Last one then. Right, these two shapes are similar. These are called frustrums. They are a cone with the pointy bit chopped off. They're called frustrums. Interesting fact. And I give you the 2 surface areas, but what I need is the larger volume. Okay, so a couple of steps to this one. You're going to have to divide the big area by the small area to get the area scale factor. Square root that to get the linear scale factor. Cube that to get the volume scale factor. And then you'll do 30 times that to get the larger volume. Easy. And you can do this in your head because all the numbers come out nice and easy. So have a go. Give it 10 seconds. Type A, B, C, or D. And then we'll do the quiz and get out of here. So 24 divided by 6 is 4. So the area scale factor is 4. Square root that to get the linear scale factor. Square root of 4 is 2. So linear scale factor is 2. Cube that to get the volume factor. 2 cubed is 8. So the volume factor is 8. So my new volume is 30 times 8, which was B again, 240. I'm sure they don't all come out as B on the real quiz, right? And that's it. That's this topic done. That would be 3, possibly 4 marks up in the higher echelons of the paper. Easy peasy. I'll leave you with a pretty mathy joke here. I was cooking on the weekend and the recipe said set the oven to 180 degrees, but now I can't open because the door is facing the wall. I think I need to quit these jokes. Oh, cheers. Cheers, Bob. Okay, I'll quit the jokes. I know. Just imagine how bored I am I get your boredom and cube that, and that's how bored I am. So I'm going to go. With a bit of luck, we'll be all back in the classroom, hopefully before Easter. All right, so we'll have some announcements soon. Please get on and do the quiz immediately. It's 5 questions, just like this. It'll take you 5 minutes tops, and it's done. Tomorrow, then, you got your My Maths. You'll have a walkthrough vid that's already been, well, it'll come out at 8 o'clock tomorrow morning. The walkthrough for My Maths. Got to get a green on that. There's 2 actually. Then some extension work tomorrow as well, if you so wish to look at the harder stuff in this topic. And then on Thursday, as normal, is the manga, right? So I hope you're all well. Miss you all terribly. And that is it. See you next week. Any questions, get in touch. Otherwise, see you later. Bye. You're welcome. Bye. 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 Bye.